Welcome to the Explainer. Today we're diving into the logic that really makes code smart, the rules that let it think, decide, and react. We are going way beyond just a straight line and into the super dynamic world of JavaScript control flow.
You know, it's a pretty common assumption when you're starting out, right? You think code is just this list of instructions that the computer follows one after the other. But what if our code could actually make decisions? What if it could change its path depending on what's going on? Well, that is exactly what we're going to explore.
The best way to think about control flow is that you're giving your program a brain. So instead of just mindlessly following a single road, it gets to a crossroads, and it can choose to go left, right, or even turn around and repeat a path, all based on conditions that we set. This is what makes software so incredibly powerful.
Okay, let's get right into it with the most fundamental decision-making tool in our entire programming toolbox, the if-else statement. It's really the simplest way to tell your code, hey, if this thing is true, do this. Otherwise, just do that.
So let's look at a quick example. Imagine we have a variable. We'll call it flag, and we set it to true. Now, our if condition here is checking for not flag, which basically just means if the flag is not true. Since our flag is true, that condition is false. So what happens? The code completely skips the if block and jumps straight to the else block.
And there you have it. The code looked at the condition, saw it was false, and correctly ran the else block. It's a really simple but super powerful example of conditional logic at work.
All right, building on that, now that we can make a choice, what if we need to do something over and over again? This is where loops come in, and we're going to start with the while loop.
A while loop is kind of like a persistent guard. It just stands at the entrance to a block of code and only lets it run while a specific condition is true. The very moment that condition becomes false, nope, the loop stops.
But, with this power comes a classic trap, especially for new developers, the dreaded infinite loop. If the condition you set up never ever becomes false, your program is going to get stuck repeating the same thing forever, and it'll often just freeze up your whole application.
Luckily, to stop your program from getting stuck, you have an escape hatch, the break keyword. So even if your loop's condition is technically always true, you can use break inside the loop to manually just jump right out based on some other piece of logic.
Now, to control a loop properly, we can use something like a counter. So here we started at 0. The loop keeps going as long as the counter is less than 3, and this is the most important part. Inside the loop, we increment the counter. This guarantees that the condition will eventually become false and the loop will end nice and gracefully.
Next up is a pretty special variation of the while loop. It's called the do-while loop. It looks really similar, but there's one key difference in its structure that changes literally everything about how it behaves.
See, a standard while loop checks the condition before it runs the code, which means it might not run at all. A do-while loop, on the other hand, runs the code first and then checks the condition at the very end. This gives it a really unique guarantee.
So let's put that guarantee to the test. We're going to set up a condition that's false right from the get-go. Our variable v starts at 0, and the loop's condition is that v has to be greater than 3. I mean, from the very beginning, this condition isn't met. So what happens?
Go on, take a second and think about it. Based on that structure we just saw, what do you think the final value of v is going to be?
The answer is 1. Even though the condition was never true, that loop is guaranteed to run at least once. The code inside the do block runs, it bumps v up to 1 before the while condition is ever even checked. It's kind of like the act first, ask permission later loop.
All right, now for our most structured and, let's be honest, probably the most common looping tool, the for loop. This is your absolute go-to when you know exactly how many times you need to repeat something.
It's really all about picking the right tool for the job. If you're looping through, say, a list of items and you already know how long it is, a for loop is almost always the clearest choice. But if you're waiting for a user to click a button and you have no idea when that'll happen, a while loop is a much better fit.
I know the syntax of a for loop can look a little intimidating at first, but it actually breaks down into 3 really simple parts, all on one line. First, you initialize a counter. Second, you set the condition for the loop to keep going, and third, you define what happens after each cycle, which is usually just incrementing the counter. It's a really neat, self-contained little package.
Okay, time to put it all together. We've learned about conditions, we've learned about a few different types of loops, so let's combine all these concepts and try to solve a more complex, kind of real-world logic problem.
Okay, here's our mission. We need to check numbers from 1 to 100. Our code has to find numbers that meet 2 conditions at the same time. They have to be divisible by 2
and by 5. And, this is important, we need to stop as soon as we found just 3 of them.
So, to build our solution, we're going to start with a for loop to go through all the numbers from 1 to 100. Then, inside that loop, an if statement checks our conditions. We use the modulo operator, that %, to see if a number has a remainder of 0 when it's divided by 2, and also when it's divided by 5.
Next, we add a counter that goes up by 1 each time we find a matching number. Then, we add another if statement to check if our counter has hit 3. The second it does, we use that break keyword to just exit the loop entirely. Our job is done.
And there's our result. The code looped, it checked the conditions, it counted our matches, and it stopped exactly when we told it to. By using break, we actually saved ourselves from checking all the numbers from 31 to 100, which makes our code way more efficient.
So we've covered conditions, while loops, do-while loops, and the really powerful for loop. You now have the fundamental tools for building programs that can actually think, react, and adapt. So the only question left is, what problems are you going to choose to solve with them?